Let's discuss about potentiometer. It is based on this principle. The potential drop along any length of the wire is directly proportional to that length. Okay, अगर हमारे पास एक वायर है जिसकी लेंथ है L और इसमें पोटेंशियल ड्रॉप है E, then E is directly proportional to L. ये वो प्रिंसिपल है जिस पे पोटेंशियोमीटर बेस्ड है. ओके, वॉच हियर. ये पोटेंशियोमीटर का डायग्राम है. These are the wires of the potentiometer, and this is the external battery. This is the rheostat, and a key is attached, K. Now let's talk about the applications of potentiometer. We can compare the EMFs of two cells with the help of a potentiometer. हम potentiometer की help से two cells का EMFs two cells के EMFs को compare कर सकते हैं. किस तरह से compare करना है देखिए. यहाँ पर ये setup बना हुआ है, ये potentiometer है और ये externally बैटरी rheostat एंड की से कनेक्ट है. ओके, यहाँ पर टू सेल्स कनेक्ट हैं. फर्स्ट का EMF है E1, सेकंड का EMF है E2. ओके, यहाँ पर एक 3-वे की कनेक्ट की गई है. ओके, और इसको कनेक्ट किया गया है एक गैल्वेनोमीटर से, और गैल्वेनोमीटर का अनदर इन कनेक्ट है जॉकी से. ओके, अब क्या करते हैं, हम की K2 में ये कनेक्शन इस्टेब्लिश करते हैं. ओके, सेल E1 को रोल में लेकर आते हैं. सेल जिसका EMF E1 है उसको रोल में लेकर आते हैं इस तरह से. ओके, और जॉकी को यहाँ पर मूव करते हैं और फाइंड करते हैं गैल्वेनोमीटर में नेट डिफ्लेक्शन. सपोज P1 पॉइंट है जहाँ पर जॉकी को लाने पर गैल्वेनोमीटर में नल डिफ्लेक्शन आता है. In that condition, this length is suppose L1. This length from A to P1 is L1. Then, according to the principle of potentiometer, we can write E1 is directly proportional to L1. Removing the sign of proportionality, take the constant. Let us take this as phi, and this would be phi L1. Take that as equation 1. We have taken this as equation 1. Okay. Where phi, this phi is the EMF or the voltage drop per unit length. Okay, now अब हमें क्या करना है, let's remove this connection. अब हमें कनेक्शन establish करना है ये वाला, और सेल E2 को रोल में लेकर आना है. सेल जिसका EMF E2 है उसको रोल में लेकर आना है. ओके, अब क्या करते हैं, यहाँ पर गैल्वेनोमीटर से अटैच जॉकी को पोटेंशियोमीटर के वायर्स पे मूव करते हैं, और यहाँ पर सपोज P2 पॉइंट पर नल डिफ्लेक्शन मिलता है गैल्वेनोमीटर में, एंड दिस लेंथ फ्रॉम A to P2 is L2. Then according to the principle of potentiometer, E2 is directly proportional to L2. Removing the sign of proportionality, taking the constant phi L2, take this as equation 2, where phi is the potential drop per unit length. Now we have two equations, E1 is equal to phi L1 and E2 is equal to phi L2. इन टू इक्वेशंस की हेल्प से हम लोग E1 एंड E2 को कंपेयर कर लेंगे. इक्वेशन 1 को इक्वेशन 2 से डिवाइड करेंगे और हमें E1 एंड E2 का रेशियो मिल जाएगा. So dividing equation 1 by equation 2, then we will have E1 upon E2 is equal to phi L1 upon phi L2. Phi is cancelled by phi, and we have E1 upon E2 is equal to L1 upon L2. This is the ratio of EMFs that we have calculated with the help of potentiometer. इस तरह से हम two cells के EMFs का ratio find कर सकते हैं with the help of potentiometer. Here we have another application to find the internal resistance of a cell. यहाँ पर हमें एक इंटरनल रेजिस्टेंस फाइंड एक सेल का इंटरनल रेजिस्टेंस फाइंड करना है। किस तरह से, देखिए, यहाँ पर हमें कनेक्ट करना है एक सेल जिसका ईएमएफ है ई, एंड इसके पैरेलल में लगाना है एक रेजिस्टेंस बॉक्स विद अ की K2। इनिशियली हम इस की K2 को ओपन रखेंगे एंड सेल जिसका कि ईएमएफ ई है उसको रोल में लाएंगे। ओके, गैल्वेनोमीटर के अनदर एंड से कनेक्टेड जॉकी को मूव कराएंगे और सपोज नल डिफ्लेक्शन मिलता है हमें पॉइंट N1 पे। ओके, एंड द डिस्टेंस ऑफ A to N1 is L1। Then according to the principle of the potentiometer, E is directly proportional to L1। Removing the sign of proportionality, taking the constant phi, where phi is the potential drop per unit length. So this would be E is equal to phi L1, and take this as equation 1. Now, अब क्या करना है हमें? अब इस की K2 को क्लोज कर दे। की K2 को क्लोज कर देना। ओके, क्लोज करने के बाद आप फिर से जॉकी को मूव कराएंगे, इन वायर्स पे, and suppose N2 is the point where the null deflection is achieved in the galvanometer, and the distance of A to N2 is L2। N2 वो पॉइंट है जहां पर इस कंडीशन में null deflection अचीव होता है, और A की N2 से जो डिस्टेंस है वो L2 है। In this condition, the potential drop across this resistance which is taken out from the resistance box, यहाँ पर resistance box में से हम लोगों ने कुछ resistance निकाला है, suppose that is R। ओके, और उस R के अक्रॉस जो पोटेंशियल ड्रॉप होगा that will be given as V is directly proportional to L2। Removing the sign of proportionality, we will have the constant that is phi L2. Take this as equation 2. Now we have these equations 1 and 2. We will divide the equation 1 by equation 2, and we will have an expression for the internal resistance that is R। Okay, कैसे करने वाले हम लोग, देखिए, इक्वेशन 1 को इक्वेशन 2 से डिवाइड करेंगे, देन वी विल हैव this E upon B is equal to L1 upon L2। The phi will be cancelled by phi। Alright, now as we have learned about, the value of E is I R plus R, and the value of V is IR is equal to L1 upon L2। Okay, now enter this I into the bracket, and we will have IR plus IR upon IR is equal to L1 upon L2। Now split up these two terms, and we will have 1 plus IR upon IR is equal to L1 upon L2, and this I is cancelled by that I. And we have 1 plus R upon R is equal to L1 upon L2, or R upon R is equal to L1 upon L2 minus 1, or we can write it like R is equal to capital R L1 upon L2 minus 1. This is the expression for the internal resistance of a cell. If we know the value of the resistance that is taken out from the resistance box and the values of the length of null deflection L1 and L2, then we can calculate the internal resistance of the cell, which is R, small r। ओके, इस तरह से इस फॉर्मूले की हेल्प से हम लोग किसी भी सेल का इंटरनल रेजिस्टेंस फाइंड कर सकते हैं। Moving ahead, we have some numerical problems, and the first problem is on the screen. Watch here. In a potentiometer arrangement, a cell of EMF 1.25 gives a balance point at 35 centimeter length of the wire. If the cell is replaced by another cell and the balance point shifts to 63 centimeter, what is the EMF of the second cell? Okay, यहाँ पर क्या given है? एक cell है जिसका EMF है 1.25. Let us take this E1 is equal to 1.25. Gives a balance point at 35 centimeter length of wire. ये balance point देता है कितने distance पर? 35 centimeter. Take this as L1. Now, if the cell is replaced by another cell and the balance point shifts to 63 centimeter, इस condition में balanced point means second condition में balance point हो जाता है 63 centimeter. What is the EMF of the second cell? तो हमें उस second cell का EMF find करना है. Applying the formula, E2 upon E1 is equal to L2 upon L1. We will have E2 is equal to E1 L2 upon L1. We can put the values to find the answer. Okay, so let's put the values. Then we will have E2 is equal to E1, that is 1.25, into L2, that is 63, upon L1, that is 35. Remove the point, take this. Now we can divide it like 5 7 is 35, 5 25 is 125, 7 9 is 63, 25 9 is 225 upon 100. So the value of E2 will be 2.25. 2.25. Okay, now no unit is given for the EMF, so we will take it just unit. So the EMF of the second cell is 2.25 units. Moving ahead, we have our next numerical. This, a resistance of 10 ohm is connected in a left gap of a meter bridge. Two resistors of 20 ohm and 16 ohm are connected in parallel in right gap. Find the position of null point on the bridge wire. So this is the condition, like a 10 ohm is connected in left gap. So the 10 ohm is connected in the left gap, and two resistors are connected in parallel in the right gap, and these are of 20 ohm and 16 ohm. Okay, are connected in parallel in the right gap. Find the position of the null point on the bridge wire. So we will have a Wheatstone bridge like this. Take this L RCM and this as 100 minus L RCM. Now we will apply the condition of the balanced Wheatstone bridge, and we will calculate the value of the position of the null point on the bridge wire. Means we can calculate the value of L. Okay, we have to calculate the value of L. Now watch here, this 20 ohm and 16 ohm, these are connected in parallel. So the resultant of these two resistors will be, take this as R parallel, RP. This would be 20 into 16 upon 20 plus 16. So this would be 20 into 16 upon 36 divided, and we will have 80 upon 9 ohm. So this is the combination, the value of the combination of the two resistors which are connected in parallel to each other in the right gap. So this is 80 upon 9 ohm. Okay, now again we will come here, 80 upon 9 ohm, and this would be 10 ohm. This is L RCM, and this is 100 minus L RCM. Now we will multiply them. Multiply the 10 ohm with 100 minus L RCM. Multiply 80 upon 9 with L RCM, and we will have 10 into 100 minus L RCM is equal to 80 upon 9 LRC. Cancel this 0 by that 0, and we will have, and cancel this RCM by that RCM, and we have 100 minus L is equal to 8 upon 9 L. So take this L to the other side, and we have 100 is equal to 8 upon 9 plus 1 L, and this would be 17 upon 9 L is equal to 100. So the value of L will be 900 upon 17, and this would be in centimeter. So this is the value of L that we have calculated as the length of the wire which is achieved from the left side. We have represented it like this. So the length from the left is L, जो हम लोगों ने कैलकुलेट की है, ये लेंथ है लेफ्ट साइड से. And this will be equal to 52.94 centimeter, and this is our answer. Here we have the next numerical, which is a meter bridge is balanced with a 20 ohm resistance in the left gap and a 30 ohm resistance in the right gap. If 20 ohm resistance is now shunted with another 20 ohm resistance, find the shift in the null point. Watch here, यहाँ पर two conditions हैं. In the first condition, the left gap has the resistance 20 ohm and right gap has it 30 ohm. This we have as LRCM, and this we have as 100 minus L RCM. In this condition, we have to calculate the value of L, that is the length of the length of the wire for which the null deflection is achieved. यहाँ पर हमें L की वैल्यू फाइंड करनी है. ओके, कैसे फाइंड करेंगे? Multiply this with that one and multiply this with this one. So we will have 20 into 100 minus L RCM is equal to 30 into L RCM. This RCM is cancelled by that RCM, this 0 cancelled by that 0, and we have 100 minus L is equal to 3 by 2 L, or 100 is equal to 3 by 2 plus 1 L. Further solving this, we will have 100 is equal to 5 by 2 L. Divide this, and we have the value of L, which is 40 centimeter. This is the condition 1, in which we have the calculated value of L. Take this as L1, and L1 is equal to 40 centimeter. Now move to the second condition. In the second condition, if 20 ohm resistance is now shunted with another 20 ohm resistance, then what happens? Then we have to calculate the value of the second null point position, that is L2. 20 ohm resistance को शंट किया जाता है another 20 ohm resistance के साथ, तब हमें फाइंड करना है कि नल पॉइंट में शिफ्ट कितना होगा. फर्स्ट कंडीशन में हम लोगों ने नल पॉइंट का फाइंड किया है लेंथ, दैट इज 40 सेंटीमीटर. ओके, इसी तरह से हमें L2 फाइंड करना है. ओके, और L1 और L2 में शिफ्ट फाइंड करने के लिए हमें इनका डिफरेंस फाइंड करना होगा. सो वॉच हियर, this is the 20 ohm and here this is 30 ohm. According to the question, 20 ohm resistance is now shunted with another 20 ohm resistance. Shunt means it is connected in parallel. So connect this with in parallel with the 20 ohm, and here and here this we take as LRCM, and this is what we take 100 minus L RCM. Okay, the resultant of this 20 ohm and this 20 ohm, these are connected in parallel, so the resultant of these two resistors will be 10 ohm. So take this here as 10 ohm. Now we can calculate the value of L for the second condition. Multiply this with that one, multiply this with that one. So we will have 10 into 100 minus L RCM is equal to 30 into L RCM. Cancel out by this RCM by that RCM, and this 0 by that 0, and we have 100 minus L is equal to 3L, or we have 100 is equal to 4L. Solving further, we will have L is equal to 100 upon 4, and this would be equal to 25 centimeter, and take this value as L2. So we have the value of L2, which is 25 centimeter, and we have already find out the value of L1, which was 40 centimeter. Okay, फर्स्ट कंडीशन में नल पॉइंट की पोजीशन थी L1, दैट इज 40 सेंटीमीटर. सेकंड कंडीशन में नल पॉइंट की पोजीशन थी L2, दैट इज 25 सेंटीमीटर. हमें फाइंड करना है कि नल पॉइंट में शिफ्ट कितना हुआ, मींस L1 एंड L2 का डिफरेंस फाइंड करना है. सो लेट्स फाइंड आउट द डिफरेंस. शिफ्ट इज इक्वल टू L1 minus L2, 40 minus 25. So this would be equal to 15 centimeter. And this is our answer. That's all for now. See you again. Thank you.